Okay, picking up right where we left off, we got a hiker whose eye level is 2 meters above the ground and wants to find the height of a tree. He places the mirror horizontally on the ground 20 meters from the base of the tree and finds that if he stands at a point C, which is 4 meters from the mirror B, he can see the reflection on top of the tree. How tall is the tree? So I'm not even going to set up a proportion for this. Just realize that to go from the height of him to the distance of the mirror is times 2. So that's going to be the same thing. It's going to be some number times 2, which means 10. Alright, so again, it's good to set up a proportion. But at the same time, let's just use logic when we can do it. Alright, let's make these problems easy. Let's work hard, not necessarily smart, although we probably do want to do both. Logan places a mirror on the floor 220 centimeters from the base of a wall. Alright, so here's the wall to the mirror. It's 220 centimeters. Alright, he holds a flashlight 130 centimeters above ground. So this distance is 130. So let it be known that me labeling this picture, it really helps it out. Alright, draw pictures when necessary. Label them when possible. Alright. She shines the beam onto the mirror. How far must Logan stand back from the mirror so the height of which the flashlight shines on the wall is 100 centimeters greater than which Logan holds the flashlight? Alright. Ooh. So this is a little bit weird. Alright. We need to know this distance. How far should Logan stand back from the mirror? Alright, that's our variable. Alright, now the weird part is kind of awkwardly phrase this. We want this distance to be 100 centimeters greater than the height of which Logan holds the flashlight. So this is going to be 230 centimeters. Alright, whoever made this problem was a little extra when they wrote it. I don't know why they would set it up like this. Alright, but anyways, nonetheless, once we get here, it's just going to be 230 over 220 equals 130 over x. And on this left hand side, excuse me, we can quickly say those zeros cancel out. Then we cross multiply. I'm going to get 23x equals 130 times 22, which is 2860. And then divide it by 23. X equals 124.34. Alright. So, the knowledge check on page 34. You can go do that on your own, or you can just listen to this video. But I'm going to just talk through these problems, and then we're done with today's lesson. Alright? So, Priya and Mira are standing next to each other. Priya casts a 10-foot shadow, and Mira casts an 8-foot shadow. Who's taller? Alright? So look, they don't even have to see each other. Priya has a shadow bigger. Alright? A bigger person is going to cast a bigger shadow. So we can quickly say, well, that's obviously Priya. Alright? A tree outside Ellie's building casts a 125-foot shadow. At the same time of day, Ellie casts a 5.5-foot shadow. If Ellie is 4 feet 10 inches tall, approximately how tall is the tree? And also with shadows, a little, as I draw this picture, a little history lesson. Ancient Greeks used shadows to determine the circumference of the world 300 BC. So thousands of years ago, just using shadows and all this stuff, they're able to say, well, the Earth's circumference is approximately this. And that was thousands of years ago. Now, today, people still think the world is flat. When the ancient Greeks knew thousands of years ago, that wasn't the case. Alright, oops. To Ellie's tree, as I was telling that story, I messed it up. The shadow is 125 foot. Alright, we don't know the height of the tree. Ellie, on the other hand, here's Ellie, wearing a dress. Crazy hair, hasn't done her hair in quarantine. Ellie is 4 feet 10 inches, so this is kind of awkward. It has a 4 feet 10 inches. Let's translate that to decimal. 10 inches over 12 inches, 4.8. All right. because then her shadow is listed as 5.5. This is a little tricky, but then we just say T over 125, 4.8, because a 410 is not 4.10. Please realize that. Let me get that, cross multiply. Again, it's actually 0.88 or 0.83333. I have some rounding in my calculator going on. But if you plug this into your calculator, do all the calculations correctly, which I did not do. Hold on. All right, there we go. The tree is going to be 109.8. Again, just cross multiply it and solve. All right, some similar problems. Cameron's 5 feet tall, has a 12-foot shadow. A nearby building casts a 78-foot shadow. So hopefully we'll call that B. Cameron's 5 feet, 12-foot shadow. The building casts a 78-foot shadow. Cross multiply. All these calculations will take place off screen. It's a mystery how I got these numbers. B equals 32.5. The Empire State Building is 1,250 feet tall. At 3 o'clock, Pablo stands next to the building and has an 8-foot shadow. He is 6 feet tall. How long is the Empire's building shadow at 3 o'clock? Fun fact, I've never been to New York City. Doesn't really sound that fun to me. All right, so here's a detailed picture of the Empire State Building. That's about as accurate as I can draw it. Put an antenna at top. All right, now it's 1,500 feet. How long is the shadow? Well, Pablo is only 6 feet tall and has an 8-foot shadow. All right, so I'm gonna say 1,500 or 1,250 over the length of the shadow that we don't know is equal to 6 over 8. And again, it's just a matter of cross multiplying and solving. The more you do this, the better you'll be at using a calculator, which is really actually a good life skill. Shadow is 1,666.6 repeating. All right, that's the length of it. All right, and then last problem. Ray is outside playing basketball. He is 5 feet tall, casting a 12-foot shadow. So Ray is 12 feet, has a 12-foot shadow. We know a basketball hoop is 10 feet. How long's the shadow? You can use some logic here. It's just gonna be 24. All right. If we're doubling 5 to get to 10, that would be doubled as well. All right. So sometimes you can just think about these problems, especially as you do them more and more.